All right, so this is 5.4. I wanted to kind of redo the video on section 5.4 because I don't think I did a very good job. Well, I shouldn't say that. I should say that I used to teach long division, but it really is a lot different in terms of the way it looks. And I don't think we need it, so we're going to stick with synthetic division. The purpose of this lesson is to show you what to do when the remainder is not 0. So, hold on a second, I get some writing utensils. Okay, so on section 5.4, I started out by asking, will the remainder always be 0? The answer is definitely no. Now, I know in all those sections we've done before this, the remainders have been 0, but that was for a particular point. Now we're opening it up and saying, well, what if the remainder is not 0? Remember that if something is said to be a factor, they use this term factor, then it goes into that evenly. We've talked about how 6 divided by 2 is 3 with the remainder 0, right? Now, would we ever write something like 3 and 0 over 2? Of course we wouldn't write that, because we know that it's just plain old 0, so we never write this part. It's just plain old 3. But the point I was trying to make here, 13 divided by 7, when you were in elementary school, maybe you wrote it 1R6, 1 remainder 6. But then when you got into middle school, you said, oh, hey, the remainder is 6, but we're dividing by 7, so the divisor was on the bottom. So we said 1 and 6/7. Now, did we ever write it like this, 1 plus 6/7? The answer is no, we never wrote it like that. But it does mean the exact same thing. So, what we're intending to do when we do this division is synthetic division. Now, you know, in the last sections we were given a hint. They said things like, 1 is a 0, 2 is a 0, -7 is a 0, and we had to use that in synthetic division. Well, now the hint is less direct. They're saying divide by x minus 2 in this particular problem. Well, for those of you who don't know, take what you're dividing by, set it equal to 0, and solve. That's going to tell you what goes inside the box. Now, you know the top, that's the coefficients of what's on the top of the fraction, 5x squared minus 8x plus 3. And so that's the 5, the -8, and the 3 are going to go there. And then we're going to go through the process, drop the 5 down, and we multiply, and then we add down the column. And then we repeat that, multiply, and add down the column. And so we can see that the remainder is not going to be a 0. It's a 7. How do we write remainders? Right here. We put the remainder part on top of a fraction. What do we put on the bottom? Exactly what we were dividing by. We were dividing by x minus 2 in this question. Well, after you have the remainder, then you have the constant, then you have the linear term. If there was another term, we would have a quadratic term. So remember that the 2 here represents plus 2, that's just your constant, and the 5 represents your linear term, 5x. If you look down there at example 3, very similar type of question. We're dividing everything by x minus 3. That goes with a 0 of 3. And we go through the process, carry down, and we do the multiply, add kind of thing, and we end up with a remainder of 8. So that's 8 over x minus 3, because that's what we're dividing by. The next thing's your constant, and the next thing after that's your linear. So there's your answer, 5x plus 2 plus 8 over x minus 3. Pause all this when you get to a place where you need, just make sure you're pausing and then listening as we go, because I know I'm going a little bit fast. Okay, so now, same thing, x minus 1, that gives me positive 1. Put your coefficients, your 1, your 3, your 1, your negative 3. We should end up with, sorry for yawning. I know you guys hate yawning because that means you'll yawn, and then you blame me, which I understand, but I'm tired. So, I get a remainder of 2. That's 2 over x minus 1. The next thing's your constant. The next thing's your linear. And the last thing, which is the 1 over here, is the squared term. This one had a squared term in it too. So remainder, constant, linear, squared, or quadratic. I always go from right to left because you guys make fewer mistakes when you go right to left. Okay, let's see what's on the next slide. All right, now don't worry about the remainder theorem. We'll come back to that thing down there, this remainder theorem idea. That's going to be for later. Okay, so this question is talking about or asking you, is the binomial a factor? Now, if something is a factor, that means the remainder has to be 0. If the remainder is 0, then we're going to say yes. If the remainder is not 0, we're going to say no. So this one doesn't require me to know the polynomial answer. All I have to do is find the remainder. So we're going to do our synthetic division. Remember, if you don't know, set the factor equal to 0 and solve. Now, for those of you who do know that process and you understand it, that's the one step I said you could avoid. Okay, so the x plus 4, that's a negative 4. That goes in the box. And we write out our coefficients, 1, 11, 22, negative 22. And then we carry down the 1. And we multiply and add. And multiply and add. And multiply and add. Looks like we get 2, and 2 ain't 0. So that means, is the remainder equal to 0? No. Therefore, we choose no. It is not a factor. Like I said, we'll come back to that remainder theorem. Okay, so x plus 6, that means the box is going to have a negative 6 in it. Going to go through the process, the synthetic division. We do end up with a 0 this time. Right? Multiply, add, multiply, add, multiply, add. We end up with 0. So that means, of course, we're going to conclude yes. What if I accidentally did this question and I made a mistake? Now, for those of you paying attention, you see I already made my mistake, but, you know, I'm going through the motions here. I bring down the 1, I multiply, and then I add, and I multiply, and I add, and then I multiply, and I add. And let's say I got a remainder of 600. Now, we all know that's wrong. But what would somebody make as a conclusion if their remainder was 600? I would say that they would probably have to say no. They would conclude it's not a factor because the remainder is not 0. But if you say yes to the, even though you got the wrong remainder, then I know you have no clue what's going on in terms of what remainder goes with the word factor. Therefore, someone who gets the wrong remainder but concludes no is going to get more partial credit from me because I understand that they know what's going on with the word remainder 0 and factor. But someone who gets a non-zero remainder and then slaps yes is going to lose credit, not only for making a mistake in their synthetic division, but also because they made the wrong conclusion based on that information. So you might say, well, the answer to this question is yes. That's true, but it better match your remainder. If it doesn't match your remainder, then you'll lose more partial credit. Okay, let's see what we got. Something on the next slide. All right, so here's another example of synthetic division. Keep in mind that when we're doing synthetic division, your answer must be a polynomial. Now, I know the couple last questions we were doing, we were looking at how do you determine if things are factors or not. We look for the remainder to be 0, and we didn't write out answers like this. So just remember, you got to have polynomials when you're doing synthetic division. If that's what they're asking me to do, if they're saying do synthetic division, they're not just saying, hey, is this a factor or not? Then you have to go all the way to the end. You have to look at this and go, oh, x minus 5. Well, if I solve that for 0, I get 5. 5 goes in the box. Oh, 1, 3, so forth, carry down the 1. Multiply, add, multiply, add, multiply, add. Hey, we got 176 for the remainder, right? That goes on top of the fraction over what we were dividing by, x minus 5. What does the 35 represent? That is your constant. What's the 8 represent? That's your linear. What's the 1 represent? That's your quadratic. But anyway, this is what I'm expecting you to do. Now, you don't need to draw the arrows. In fact, if this makes sense to you, I don't even need you to write that out. You can go straight to 5 and then start doing your synthetic division. If the arrows help you to focus. Now, somebody made a good suggestion that I would suggest to you when you're doing this so you don't make mistakes. Use a calculator. Now, it's true that I want you to be able to do things without a calculator. I mean, that's just me as a math teacher. I want you to be able to do things without a calculator. I'm not taking your calculator away from you. And so if it makes more sense, if you really want to do 3 plus 5, just to make sure you're right, then I would do it. If you really want to do 5 times 8, just to make sure you're right, then do it. It'll help you maybe gain a little bit more confidence that you're doing your synthetic division correctly. Another synthetic division question. Now, in this particular one, they said something at the beginning that made me think that my remainder was going to be 0. It said, completely factor it. Why would they tell me to factor something if it won't factor? So that's what was running through my mind when I saw this. I was like, well, wait a second. If they're saying to factor it, then they're basically telling me the remainder is going to be 0. So I'm dividing by x plus 5. We know that when we set that equal to 0, that ends up giving me negative 5. So we put that in the little box. And then you've got your 1, your 7, and your negative 15, and you go through your synthetic division. Multiply, add, multiply, add, multiply, add, after you carry down the 1. And we do. We end up with a 0. So, definitely means what I'm going to have left is factorable. I get negative 3 is my constant, 2x is my linear, x squared is my quadratic. And then I can think of things that multiply together to give me negative 3, that add up to positive 2. And obviously 1 and 3 are the only two choices. It's just a matter which goes to the plus, which one goes to the minus. And if you want to add them up to 2, you got to have a positive 3 and a negative 1. Where does x plus 5 come from? Oh, that's the original one. That's right. There will be 3 factors in your answer. It's just on the answer blank line, it looks like they already have one of the 3 on our list is called the remainder theorem. Now, I'm going to go back to question 4. I talked about a little while ago that the remainder theorem would be something we'll talk about later. So, the remainder theorem helps me find the remainder quickly. What does it tell me to do? Take the 0. Take the 0 from the denominator and substitute that 0 into all the x's from the numerator. So you can see that I took the negative 4, which was what we had in x plus 4, and I went to the binomial and I plugged it in for every single x value that we have here. Now, look over here what I typed, what I wrote out. You must use parentheses, and they better be in the right spots. Or else you won't come up with the right remainder. Now, can you do the remainder theorem and then do synthetic division on the side in order to check your answer to make sure they match? That's true. That's true. If I ask you for the remainder theorem only, then you better have the remainder theorem, not just synthetic division. Now, if you type this in correctly, you should get 2. You can type it out and see that you're going to get 2. Likewise, on number 5, if I take negative 6 and I plug it in, right? Negative 6 to the 3rd power plus 9 times negative 6 squared plus 14 times negative 6 minus 24. And, I'm just going to check on my calculator just to make sure. Parenthesis, negative 6, parenthesis, to the 3rd power, plus 9, parenthesis, negative 6, in parenthesis, plus 14, parenthesis, negative 6, and parenthesis, minus 24. Whoa. Oh, I forgot a square. No wonder. Here's my mistake. I should have gotten 0, right? But when you look at my calculator screen, you can see I got negative 378. I noticed right there I forgot my square. So I'm going to repeat what I did and then come back in here. Now, for those of you who want to insert something into a line on a graphing calculator, if that's what you have, right above the delete key, the DEL, the delete key, you see INS for insert. We'll type that. And now I can type stuff in without having to retype any part of that line. So obviously I can put my square on there because that's what I was missing. Hey, look at that, I got a 0. through the remainder theorem on this one. It would be 5 to the third plus 3 times 5 squared minus 5 times 5 plus 1. Parenthesis 5 to the third plus 3 parenthesis 5 squared minus 5 times 5 plus 1. 176. Dang, how did I know that was going to happen? Ding, 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 ding. They match. So that's really the remainder theorem. So we can use the remainder theorem and take 4 and plug it back into these two. 6 times 4 squared minus 7 times 4 plus 1. I got 133. And if we want to come over here and just double check, 6, 33. 4 times negative 33 is negative 132. Oh, that should be a positive 33. That's why. I was like, man, how does that not work? Yeah, you make little mistakes like that, and that's what costs you.